Now let's take some time and look at the objectives for this lesson. By the end of this lesson, you will be able to define and explain the concept of work and energy. Distinguish between potential energy and kinetic energy. Perform calculations involving work done. Let us begin by asking, what is work done by a force? Work is said to be done when a force causes an object to move in the direction of the force. In doing work, energy is transferred from one object to another and moves the object in the direction of the force. The greater the force applied, the greater the distance moved in the direction of the force, and the more work is done. So the question is, when is work done? Work is done on an object if these two things happen. First, the body moves as the force is applied. And secondly, the direction of the object's motion is the same as the direction of the force. The animation on your screen illustrates the meaning or examples of work done in science. In the first activity, we have pushing a car to move it along a straight line. And you can see the direction of motion. Now let's have a remark. And the question is work done in this activity? Yes, work is done because the pushing force moves its point of application in the direction of the force, and the force exerted transfers energy to the car, causing the movement. In the next activity, pushing a car along a straight line, but the car does not move. The question is work done in this activity? No, since the force exerted does not move the car. In our next activity, that is lifting a load from the ground onto the head. In that activity, yes, work is done. Work is done on the load as the man lifts it up. This is because the man transfers energy to the load which lifts it up. And this is done in the same direction as the load, increasing its potential energy. In the next activity, holding a load and walking horizontally. In this activity, no work is done. This is because force is applied in moving the load horizontally. So what it means is that the direction of application of the force is different from the direction of motion of the object. In the next activity, holding a load and standing at one place. And in this activity, certainly no work is done because the force applied does not move the load at all. Reading your notes, and per the principle of science, in this activity, no work is done. Though the text may be difficult, it does not involve exerting force, and therefore no work is done. Now let's take a moment and consider the women on your screen drawing water from a well using a bucket and rope. Apply the concept discussed and decide whether they are working scientifically or not. Your guess is as good as mine. They will be doing work by exerting an upward pulling force on the rope, which will transfer energy and move the object upwards. Work done by a force is therefore defined as the product of the force and the distance moved by the object in the direction of the force. Mathematically, it is defined as W is equal to F times D. That is, capital W is equal to capital F multiplied by capital D. The SI unit is Newton meter. That is capital N, small m, or joule, which has the symbol capital J. Note that the name joule begins with lowercase j, but the symbol is uppercase, that's capital J. A joule is the work done when a force of 1 Newton moves an object through a distance of 1 meter in the direction of the force. Work done is a scalar quantity. This is because it has only magnitude but no direction. Let us consider some work examples. If a girl pushes a box against frictional force of 150 newtons for 5 meters in the direction of the force, how much work did she do? Solution. Now let's use the problem-solving approach or strategy. So we start by analyzing the problem before solving it. Let's start by listing the known variables and the unknown variables. For the known variables, we have force of 150 newtons. We have work done, which is an unknown variable, and we have distance of 5 meters. Let us now use the appropriate formula to calculate for work done. And by definition, we know that work done is equal to force times distance moved in the direction of the force. By substituting the figures into the equation, we have 150 newtons multiplied by 5 meters. And this gives us an answer of 750 joules. Therefore, work done in pushing the box against friction is 750 joules. Let us now look at work done against force of gravity. Work done against gravity on an object of a certain weight in lifting it through a vertical distance is work done is equal to weight multiplied by the height above the ground. Let's consider another work example. A girl lifts a book of weight 24 newtons from the floor to a bookshelf of 4 meters high. How much work is done? So we will still apply the problem-solving approach or strategy by listing the known variables from the unknown variables. So for the known variables, we have weight of 24 newtons, we have distance of 4 meters, whilst for the unknown variable, we have work done, which we are after. Let's use the appropriate formula to solve this problem. By definition, we know that work done is equal to weight multiplied by the height above the ground. So we substitute the figures into the equation.
Work done is equal to 24 Newton multiplied by 4 meter, which gives a final answer of 96 joule.
Therefore, the work done by the girl in lifting the book onto the shelf is 240 joules.